To problem number 2, it says find the conductivity of a metal at a temperature of 110 degrees Celsius if its resistivity is 0.0056 at a temperature of 20 degrees Celsius and the coefficient of resistivity is 0.0095. If the length of the metal wire is 10 meters and radius is 3 centimeters, what is its resistance at 110 degrees Celsius, right? So from resistor theory, we know that the resistance of a wire is equal to its resistivity times its length over its area. So the length is this length and the area is the cross-sectional area of the wire. The resistivity actually turns out to be temperature dependent. It's equal to its resistivity at some base temperature 1 plus alpha T minus T0. So usually most data tables will give you the resistivity of a material at a temperature of 20 degrees Celsius. That's like the base temperature. So T0 is usually 20 Celsius. In this case, it tells you the resistivity is 0.0056, that's rho 0, at a temperature of 20 Celsius, right? And the coefficient of resistivity is alpha. So alpha is sort of telling you how fast the resistivity of the wire is increasing. The reason resistivity increases is that when you heat the wire, the molecules of the wire move faster and faster and faster, and they get in the way of the electrons trying to flow through it, the current trying to flow through it, right? So they kind of resist the flow of electrons more than they would if they were colder, right? Semiconductors, on the other hand, are different. Semiconductors, when you increase their temperature, their resistivity goes down. They actually have a negative alpha, a negative coefficient of resistivity. That means their resistivity decreases, right? So what we have to do in this problem is first calculate the resistivity. So rho 0 is equal to 0.0056, 1 plus the coefficient of resistivity, 0.0095, okay? And then we have the temperature that we're interested in is 110 minus 20. So we calculate that, 0.855, and then I add 1 to that, 1.855, then I multiply it by this, the resistivity, 10388. So that's the resistivity. The units of resistivity are ohms times meters. It actually has to be like that because the units of this is ohm, this one is meter, this one is meter squared, right? And then the meter cancels the meter, and then the resistivity rho has to be ohms times meters. So from the very definition of resistivity, it's going to be ohm meter. The conductivity of the material is opposite of the resistivity. It's basically the reciprocal. Conductivity is 1 over resistivity. So if I go that to the negative 1, that gives you 96.26. And the units are ohm negative 1, meter negative 1. The conductivity of a material tells you how good of a conductor it is. The resistivity of a material tells you how good of a resistor it is. So what it's asking here is it's asking for the conductivity of the material. 96.26 ohm inverse, meter inverse, okay? So materials that are good conducting, we call them conducting materials. They are good conductors, poor insulators, right? So good conductor, if this is high, that's a poor insulator. So the resistivity is low. If the resistivity is high, it's a good insulator, then the conductivity will be low, it'll be a poor conductor, right? So metals tend to have high conductivity, low resistivity. They're opposite because they're good conductors, they are not good insulators of electricity. The same thing goes true with heat. A good heat conductor is a poor heat insulator, and vice versa, okay? So what next thing we're going to do is calculate its resistance, right? Resistance of the wire, we're going to use the resistivity which is 0.010388, multiplied by the length of the wire, which was 10 meters. It's a long wire. Divided by the area of the cross-section is pi r squared. Pi r squared. So in this case, what's the radius? 3 centimeters. Change that to meter, it'll give you 0.03. 0.03 squared. So the resistivity times the length over pi r squared. So 0.010 to 36.74 ohms. The resistance of the wire is 36 ohms. Okay, so you can now see how to approach this problem, the difference between resistivity, conductivity, the temperature coefficient, and all of those kinds of topics. Okay, thank you.